Videos is I went to Ingenuity and I took like the instruction portion of it and I put it on the screen. So I'm going to teach it the way that I would normally do it, but you're going to see kind of like the same stuff that they would have, right? So one of the first things that you'll be doing is learning how to do like elimination, which we've done in class already, but as a review, they gave this example, and their instructions are, you know what, we're going to create coefficients. Remember that a coefficient is simply just the number that's in front of the variable, like right there, and we're going to find additive inverses for one of the variables. And then we'd add them, we'd solve, we'd substitute and check, right? So it's kind of the same thing that we've done. I'm gonna leave the instructions here. What I would really recommend is that you get like a paper, a pencil, a notebook or something, and you should try to write it as we go, right? Because it's you always learn better when you write it down and you can visually see what you're doing. All right, so I'm gonna go ahead and start off by doing this. It says create coefficients that are additive inverses of one of the variables. Okay, so choose one of them, a new one you want. So I'm looking at the variables y's, I'm looking at x's, I'm thinking, okay, let's see, the coefficient here is a 7 and this is a 9. Now if you remember, in order to eliminate, you need to have opposite signs. And then we also needed to have the same numbers. And we always want to just check to see if we have any of that, right? So we have a negative, a negative, so they're not opposite. These are not opposite, they're both positive. The numbers are both different here, and they're both different there. So we have to basically get all of these. So now we have to just choose, okay, well, which one's like easier, right? Is it easier to eliminate the y's or maybe the x's? Well, these have lower numbers and these have higher numbers. So I'm gonna go ahead and eliminate x. The way we do that is we're going to find the LCM, the least common multiple. So for 3x and for 5x, we're choosing, or we're counting by threes, and then we'll be counting by fives, right? So 3, 6, 9, 12, 15, 18, and then counting by fives. And we're just looking to see, all right, well, what number do they both have in common, right? The first thing you'll see here is a 15 and a 15. So that's the number that we want to get both of the equations to be for the coefficient term. Okay, coefficient again is just this number, the number in front. So we want to change this to become a 15. The way we do that is through multiplication. And we got to think to ourselves, what do you multiply 3 by to get to 15? Or we could just multiply by 5. And what do we multiply this 5 by to get to 15? And that would be 3. Okay, from here, we're just going to distribute to each term. So 1, 2, 3, right? Don't forget all 3 of them. And we're going to rewrite it as 15x, right? That's the 5 times 3 minus 35y. It's 5 times 7 equals 25. And then on the bottom, also distribute to each one. So we have 15x, okay? 3 times negative 9 is negative 27y. And then 3 times negative 5 is negative 15. Right, so here we now have the same coefficients and we're going to add them down, right? So that's why we're going to use additive inverses here, right? We're just adding straight down each column. So 15 plus 15, well, what would happen if we did this, right? This would actually be 30. And then this would be a huge number, and this would be a huge number. And so if we were to do this, I'm gonna go through with this. I know some of you guys are already noticing a mistake, okay? Nothing cancels out. Well, why not? Well, if you go back to our 2 criteria, okay, we have that they do have the same numbers, but we don't have opposite signs yet. So instead, what we should have done is that we should have multiplied this bottom one by a negative, or the top one, doesn't matter. So if I multiplied by a negative, what would change? This would be a negative 15. This would then become a positive 27. And then negative times this negative would then become a positive 15. Okay, now if we were to go and add straight down, 15 minus 15 cancels out. Negative 35 plus 27 is, I believe, negative 8y. And 25 plus 15, let's see, 0, carry the 1, so this becomes 40. Okay, so that's the first and the second rules that they gave us, or the steps that they gave us. Then after that, we're going to solve for any of them. Now, we're solving for y, so we just want to get this by itself. Divide both sides. Okay, and we get that y is equal to negative 5. Right? Then what do we do? As you remember, we started off with two variables. We need to then substitute back into either of the original equations. So choose any one you want, doesn't matter. I'm going to choose the one that has the lowest numbers, right? So this has a 3 and a 7, this has a 5 and a 9. So I'm going to choose the first one. 3x minus 7y. Now you could choose anything. And we're going to substitute, right, the value that we got. So in this case, we got y equals negative 5. So we're going to search. And whenever we see a y, we're going to just replace that with negative 5. Okay, and you're going to see I'm going to bring everything straight down. So the 3x is going to come straight down. Right, nothing else is going to change except what we substituted for y. And then now that we have a number there, we can solve for x. So we get 3x, negative 7 times negative 5 is 35, equals to 5. And then to solve for this, right, we're going to subtract 35 from both sides, okay, by using the inverse operation there. Then 3x comes straight down, that's this guy, equal sign, right? 5 minus 35 is, let's see, negative 30. And then to get the x by itself, divide both sides by 3, and we get that x is negative 10. So our final answer, okay, because we can't just leave it like that, is going to be a ordered pair, right? Ordered pair or coordinate is x comma y, and we're just going to replace or just fill it in like this. So that would be our answer.